This conference will now be recorded. This conference will now be recorded.
Very good evening, students. I hope you are doing well and preparing for the JEE Mains exam. The people who had exam yesterday and today are done, but the people who are going to write the coming days, this class may be helpful for them. So today we are going to start discussions on JEE Main paper 2021 17th March shift 1 paper. Okay, so in this PYQ discussion sessions we have covered 2020 all the papers. 2021 we have covered the July, June and July, August paper, and now I'm starting with March paper. Okay, so let us start our discussions. This question is saying the vernier scale used for measurement has a positive error of 0.2 millimeter. Vernier scale used for measurement has a positive error 0.2 millimeter. Okay, that means positive error is given anyway. If while taking a measurement it was noted that 0 on the vernier scale lies between 8.5 centimeter and 8.6 centimeter, vernier coincidence is 6, then correct value of the measurement is dash centimeter. So we know if you have main scales like this, okay, approximately like this, and you have vernier attached to this. Okay, vernier will be somewhere like, say you have vernier scale which can be movable. So vernier 0 is here somewhere. Okay, so you have vernier scale, this one. All right, so this is B and this is main scale, say. So how is the main scale reading taken? Do you know that? See, after keeping the object, okay, whose length has to be measured between the jaws of the main scale and the vernier, the main scale reading, see the total reading will be total reading, let us say that is R. The total reading will be MSR, main scale reading, plus VSR, vernier scale reading, into the least constant. Okay, least constant, let us say LC. LC, L dot C. Okay, so this will be the total reading. If there is error, then that error has to be either added or subtracted according to the nature of the zero error. Okay, so if zero error, the division is given, then you have to sometime multiply LC. Here zero error is given with a unit, so we don't need to worry about this multiplication with LC. So look, this MSR, how the main scale reading is taken. Main scale reading is taken till that point. Suppose in this case this 0 is actually crossing this one. Okay, so when your vernier 0 will be crossing some line, suppose I have this one, just let us take this situation which is given in the problem itself. Main scale reading is taken as the reading which is actually crossed by this 0, vernier 0. Suppose my vernier 0 is somewhere here, as it is said, in between. So this is my vernier 0, in between these two readings, 8.5 and 8.6. So always the main scale reading has to be taken as the one which has been crossed, okay, which has been crossed by this 0. So you should not take this one. Okay, so this is where the utility of this vernier reading is coming up. Okay, so you don't need to worry about this reading exactly. That is where the vernier scale is actually helping us to get the readings in between. We should not take the reading in between. We have to take the reading which has been just crossed by the vernier 0. So in this case, the vernier 0 was in between 8.6 and 8.5 and 8.6. So I have to take the main scale reading as 8.5, which was crossed by this 0 vernier. Okay, vernier scale reading. So I'm just cleaning this just for the understanding. We had these figures. Okay, anyway, now I have got MSR. MSR is 8.5. This is in centimeter, right? Then vernier scale reading, see the coincidence, so we have to see coincidence is 6 and LC is 0.01 in centimeter. Then zero error, if it is positive, then I have to minus it. Okay, this is in millimeter, so I have to write 0.02 in centimeter, right? The whole reading will be in centimeter. So this will give you 8.54 centimeter if you do this calculation. So here the point was, see this one, the main scale reading, taking the main scale reading. How to take that? The one which was actually crossed by the 0 of the vernier. That's all. Okay, otherwise things were easy. All right, so now I have got the second problem. So this second problem saying a triangular plate is shown. So in this figure you can see this triangular plate, and this triangular plate is actually like an equilateral triangle here, and this is acted upon by a force. You can see that this force 4I cap minus 3J cap. Okay, this is the force direction is also shown here, and this force is applied at this point P on the plate. Now you have to find out the torque at P, torque at this point P with respect to point O. Okay, with respect to point O, you have to find out the torque. So what we know, torque is the force applied. Okay, we have to take the cross product. Okay, cross product R cross F. R is the position vector and F is the force applied, or you can say the force, magnitude of the force into the perpendicular distance. Okay, perpendicular distance from O, perpendicular distance from O, distance from O. Okay, this will be magnitude into sine of the angle between the force and the perpendicular distance. That angle, okay, anyway, perpendicular distance means you don't have to write down this theta and all. So perpendicular distance you had to find out. Okay, so if you do in terms of vector, it becomes a little bit easier. Better to write this expression R cross F. Okay, so if we know what is r, we have to find out. So what is r? This position vector I have to write down. Okay, this OP. So r is nothing but OP. So how do I write? See, I need to know the coordinates of these 2 points. See, this point is exactly middle point. You can see that. So this will be 5 centimeter here. So this point has got x coordinate 5 and y coordinate. Y coordinate is the height. Okay, root over 3 by 2 into a. So this will be 5 root 3 centimeter. 5 root over 3 centimeter. So this is actually the coordinate, and this q point has got a coordinate 0, sorry, 10 comma 0, 10 comma 0. So how do I write? See, there are two torques you have to find out. One with respect to O, another one with respect to Q. So let me write, this is R1. So R1 is OP. So let us write in terms of vector OP. How do I write? I just take 5 minus 0 I cap plus, so y coordinates 5 minus root 3, sorry, 5 root 3 minus 0 j cap. Okay, so what we get? We get R1 as 5 I cap plus 5 root 3 j cap. Now let us find out the torque. About torque with respect to O. Okay, let me write TO then with respect to O. So R cross F, R I have to write down here, j cap, R cross F. F is 4 I cap minus 3 j cap. Okay, so look then, see, I cross I will give you 0 if you go with cyclic rule. I cross J will give you something here. Okay, I cross J will give you K, but there is minus sign here, so minus 15 K cap. Similarly, this J will give you 0, but this will give you 20. So J I cap, right? J I cap is again minus K, minus K cap. So 20 root 3 K cap. So I get 5 plus root over 3, 20 root 3 into minus K cap. Okay, so this will be actually the torque about minus K cap direction. Okay, let us go for the other one. See, what is R2 here? This is R2. This is R2. Okay, this R2. This R2 is, say, this point and this point. I have to just find out. So 5 minus 10 I cap plus 5 root 3 minus 0 into j cap. Okay, so I have got minus 5 I cap plus 5 root 3 j cap. So this is my R2 vector. Okay, now let us find out torque about Q. Torque about Q, or I mean torque with respect to Q, that is R2 cross F. Okay, what is R2? We have found out that minus 5 I cap plus 5 root 3 j cap, which I have to multiply with 4 I cap minus 3 j cap. Now here it is 20, sorry, It will not be 20. See, I cross I will give you 0. Ij there will be 15. Ij will be k cap, and ji will be minus k cap, 20 root over 3 minus k cap. Okay, that's what I have written here. Let me just take k common, or minus k common. Minus k, if you write, so here it will be plus 20 root 3 with minus k cap. Okay, just to keep the uniformity, I'm just writing this way. And see, then the torques are one is with respect to O, we have got 15 plus 20 root 3 minus kk, and this one we have got here like this. Okay, so let us cross check the options. Okay, let me just, this is minus, this is plus, this is minus plus, and this will be both are plus. Okay, let us see there both plus and minus plus. Okay, so minus plus and plus, so these are actually with respect to P and with respect to Q. Okay, with respect to, sorry, with respect to O and with respect to Q. Let me cross check. Yeah, we are getting the same thing, but with uh, this is positive. Let us check whether we have done some mistake somewhere. Okay, so with this one, oh, okay, so already this was minus, right? So minus will be plus, and here I have got j I j k. So j I will give you minus, right? This will be minus. Okay, minus plus. This will be plus. Okay, in this case, minus. Okay, ij is k. Just a cross check, because the sequence, I don't know whether they have maintained the sequence, or maybe I might have uh, done some mistake while typing. So, but this is the way to do. TO 15 this. Okay, so this is positive one. This is fine. This one with a minus k cap. Okay. The second one will be minus and plus. Minus and plus. Okay, somehow I'm thinking this will be the answer, but I don't know whether they have or I have typed wrongly. Anyway, I'll confirm you in the next class. Okay, but this is the way to do the problem. Okay, solve the problem. All right. So, okay. We'll move on to the next problem. This problem says a car accelerates from rest at a constant rate alpha. So this is the acceleration, okay, for some time, after which it decelerates at a constant rate beta. That means acceleration is given and deceleration is given. So a car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta to come to rest. If the total time elapsed is t seconds, the total distance traveled is what out of these four options? This is a very good question actually. So see, there is a car, suppose, okay, so the car what it is doing, actually it is accelerated with acceleration alpha for some time. Let us say that is getting accelerated up to t1 time, okay. Then after t1 is over, the car has to stop. That's why it is decelerated, okay. After this it is decelerated, okay. Up to this it was accelerated, now it is getting decelerated. Okay, decelerated and rate of deceleration, that means deceleration is beta, and let us take the time before stop, okay. Here it is stopping, okay. Before stop it is going t2 time, okay. With deceleration beta, it takes t2 time to stop, and according to the question, this t1 plus t2 is the total time t, okay. This is given, so you have to find out how much total distance it has traveled, okay. If suppose this much is s1 and this one is s2 before it stops, then total s will be s1 plus s2. So this we have to find out, okay. So what I have supposed, that the car is traveling with acceleration alpha till t1, okay, t1 during t1 time, okay, t1 seconds. So it is accelerated for t1 seconds. So I can find out what is s1 then. Initially it was at rest, so half alpha t1 square, right? We can find out that, right? Now again, what will be the velocity after t1 seconds? The velocity will be v is equal to u plus at, where u is equal to 0, a is alpha here, so alpha t1. So can I write this t1 is equal to v by alpha? I can easily write that, isn't it? So if I put this t over here, what I'll get? I'll get half into alpha v square by alpha square. That means we get v square by 2 alpha. Okay, v square by 2 alpha. So s1 I have already got, okay, from this 2. Now I'll just consider about the deceleration. So it is stopping after t2 second. So I can write s2 is equal to half alpha, half beta t square. Okay, but here one thing more, it is actually having initial velocity, that is v t2 minus, here it is minus because this is deceleration, half beta t2 square. Okay, again what is t2? See, it starts with velocity v and deceleration beta. It is moving for t2 second before stops. So then can I write this, that final velocity 0 is equal to v minus beta into t2? This is very simple. I can write this because final velocity is 0. This is deceleration. So v, this is the initial velocity when it is starting its deceleration. So t2 I can find out as v by beta. This is very nice. Okay, so I'll just put it here with t2. Okay, so t2 is v into v by beta. So this is t2 minus a half beta, again t2 square, that is v square by beta square. Right, now look this thing, what I have got. What I have got here, v square by beta minus v square by beta with 2 here, so it will be half v square by beta. Okay, see I have got one more relation, that is t1 plus t2 is equal to t. Let us just get that one. See, we have got t1 is equal to beta by alpha. See from here, see this. Now we have got, see, t2 is equal to v by beta. I have got. So what is t? T is t1 plus t2. That is v by alpha plus v by beta, right? So from here I can find out what is v in terms of alpha, beta, and so this will be alpha plus beta divided by alpha and beta into v. This is t. Therefore from here I can find out what is t. T will be, sorry, what is v? I can find out what is v from here. Okay, so this gives you what is v. V is equal to alpha beta into t divided by alpha plus beta. Okay, I have got v in terms of alpha, beta, and t. Right, now I have to put this value here, s2. S2 is half, like 1 by 2 beta into v square. V square means alpha square beta square by alpha beta whole square into t square. Okay, this is what I have here. Okay, similarly when I have got v, see I'm just cleaning this since I have don't, okay, I don't have this space. Okay, so v I am writing here alpha beta by alpha plus beta into t. Okay, so then what I get, s1 we have found out how much, s1 we have found out v square by 2 alpha. So v square by 2 alpha, v square by 2 alpha, I'll put the value of v, that is alpha square beta square divided by alpha plus beta. Here I think there was 2 here. Yes, there will be 2 v square by 2 alpha. So this is square and t square. Fine. So I have to find out what is s. S is equal to s1 plus s2. Okay. So what are s1 and what are s2? Like, yeah. So what are s1 and s2? We have found out that, see, this alpha, actually there will be one alpha here. This alpha will cancel each other. So alpha beta square. Look, I have got here beta, one beta can be cancelled. See, I have got half, this is this one, half alpha beta square divided by alpha plus beta whole square, okay, into t square. Further here s2 is alpha square beta by alpha plus beta whole square into t square. Okay, I don't know whether these options are there. Okay, let us see how we get this. Is half alpha beta and t square common. So I have got beta from here by 1 plus, sorry, this one, alpha plus beta whole square, plus here alpha divided by alpha plus beta whole square. Okay, so this is common. So alpha plus beta, see here in the numerator there I'll get 1 alpha plus beta, and in the denominator I have alpha plus beta whole square, right? So I can strike one among them with this. So then I get alpha beta divided by 2 into alpha plus beta whole into t square. Okay, let us see the options. See alpha beta, so the last option you see alpha beta divided by 2 into alpha plus beta t square. Okay, so this will be the correct answer for this question. Okay, so alpha beta divided by 2 alpha beta into t square. So this was actually lengthy problem, and also you have to understand the languages. And the tricky point was that, so you have to just take t1 and t2, two different seconds, like different time intervals, and then try to find out what is s1 and what is s2. And also one more point was, like, from the conditions given, from there itself t1 and t2 can be found out. Finally you have to use this t1 plus t2 is equal to t also, so that you get the v. All right, so this was actually very tricky problem. I would say very tricky problem. If you don't do with very cool mind and also with patience, there is a like chance that you may not be able to do, or you may do mistake. All right, so let us go to the next problem. This problem is very simple. Let us see that a boy is rolling 0.5 kg ball on the frictionless floor, okay, with the speed 20 meters square, sorry, 20 meter per second. So a ball, it is rolled, okay, in frictionless floor. So whenever we see this kind of problem, rolling means I can consider two things. One is it is rotating, another one is it is moving. So there should be two kinetic energies, rotational kinetic energy and translational kinetic energy. Okay, so this thing I can think of. Now let us further read. The ball gets deflected by an obstacle on the way. After deflection, it moves with 5% of its initial kinetic energy. Okay, so the main point is lying, how do you calculate the kinetic energy? So what is the speed of the ball? So you know the final kinetic energy Kf is 5% of initial kinetic energy. Okay, we know mass is given if we write Vf square, and here 5 by, so 5 by, this means 1 over 20, anyway 1 over 20 into Ki. Ki means half m into V initial square. Okay, so you might be thinking I was talking about rotational kinetic energy, then translational kinetic energy, but why I'm writing only translational kinetic energy? This is because the floor is frictionless. Frictionless. So when there is frictionless floor, there is a very chance to slip. Okay, so we don't know the formula for that. When an object is rolling with slipping, we know rolling without slipping, in that case we can use V is equal to R omega. V is equal to R omega, and the total kinetic energy I can write half I omega square plus half mv square. This I am writing only when I know that the floor is having certain friction and the body is moving without slipping. So in that case I can write this. Otherwise, in this case, since the floor is frictionless and also there is no much information about this moving with slipping or rolling with slipping or without slipping, since those things are not given, we'll just take this kinetic energy as the translational kinetic energy itself. Okay, then things are easy. So this is a half m can cancel from both sides. So Vf will be Vi by this one. Okay, now what is Vi? I'm sorry, Vi, yeah, so Vi is given already, right? This is 20 and there is root over 20. Okay, so I think this will be root over 20 meter per second. And what is this root over 20? So root over 20 will be 4.47 meter per second. Okay, so option D will be the correct answer for this question. Okay, all right, so we'll go to the next problem. This is also very interesting problem. This is actually motion of a car in a flat surface, flat road or plain road, where there will be friction between the tire and the floor. Okay, and you have to take a turn. Say modern Grand Prix racing car of mass M is traveling on a flat track. See, flat track in a circular arc of radius r. So this is the circular track of radius r on the flat track. Okay, flat track. Okay, and it is moving with velocity v. See, it is moving with velocity v. If the coefficient of static friction between the tires and the track is mu s, then the magnitude of negative lift acting downward on the car is, you have to find out what is the negative lift FL, which is acting downward, it is said. Let me just show you this particular figure. Okay, look, when the car, so this is suppose the car, when it is on the circular track, you can see when it moves, it has speed along this way v, so it will be acted upon by the centrifugal force, which will be actually trying to take away from the center of the track. Okay, that will tend the car to skid away from the center. Okay, to overcome that, there should be friction, and that friction will actually work towards the center. So I can write F is equal to mv square by r. Okay, and in the whole process, see, when the car is on the track, so its weight will be downward and n will be in the upward direction. Here, one more thing is that the negative lift will be acting in the downward direction. So the n has to balance this mg, that is the weight of the car, and also the fl. Okay, so this is what is the problem. I have to find out what is n. Okay, what is n, I have to find out. Then I can find out what is fl. Fl will be actually n minus mg. So what is n? Let us say, see from here, if this is frictional force, so mu s into n, mu s into n is equal to mv square by r. So from here I can find out what is n. N is mv square by mu s into r. Okay, now let us put it here. Mv square by mu s r minus mg. Let us see the options. Okay, so yes, so this first option, yes, I have m common over here, so let us take m common. Then v square by mu s r minus g. So the first option will be the correct answer for this question. Okay, so this is the first option which is correct for this question. All right, so dear students, I hope you are understanding this. During the circular, so this is circular motion, or yeah, circular motion in a flat track, okay, or plain road. So motion of circular motion of a car in a plain road. Okay, in this case there is an extra thing, that is the negative lift, which is acting downward. This is just extra, otherwise things were all same. Okay, so if there was no negative lift, what would have been the case? The maximum speed, safe speed, see, I would have written f is equal to mv square by r v max, sorry, mv max square by r v max square by r, safe speed. And this f, if I can write mu s into mu s in, yeah, mu s into n, and n will be equal to mg. So mu s mg I can write for f. So look, the condition we know, we'll find out here. So m v max square by r. So this m will, sorry, this m will cancel each other. So v max square will be equal to mu s r g. So this is the conventional conventional circular motion of a car in flat track. Okay, so this is the conventional thing we know, but here the extra thing is the negative lift, which has been supplied by, like, supplied to the car in this case. Okay, and that negative lift we have to find out, and that we have found out like this. Okay, all right students, so I hope you have understood this. If not, you can just write in the comment box in our YouTube channel. Now we'll solve this problem. I hope this, okay, I have two more problems. So this is from KTG. A polyatomic ideal gas has 24 vibrational modes. What is the value of gamma? Okay, gamma means Cp by Cv. So dear students, we know gamma is equal to Cp by Cv, and this can be further written as 1 plus 2 by F, where F is the degrees of freedom. Degrees of freedom. So if you know for a system, if you know this degrees of freedom for a system, then you no need to find out what is Cp, what is Cv. You can directly find out what is gamma, the ratio of molar specific heat at constant pressure and constant volume. You need not know, okay, to find out what is this gamma. Okay, if you know this one, what is that? Degrees of freedom. So degrees of freedom, actually there are three kinds of degrees of freedom. One is translational degrees of freedom. I'm writing FT. Translational degrees of freedom. Translation in 3 dimensions, you will have 3 translational motion. Okay, along x-axis, along y-axis, along z-axis. So you will have 3 translational degrees of freedom. Rotational degrees of freedom, you can rotate about x-axis. The system can rotate about y-axis. System can rotate about z-axis. Okay, so I will have 3 this also, 3 rotational degrees of freedom, and I have vibrational degrees of freedom. Vibrational degrees of freedom. So this vibrational degrees of freedom, if does not, like if it is not mentioned, then we don't consider generally, but when it is mentioned, we have to really consider it. Okay, so this polyatomic system will take here, see there are 24 vibrational modes. And so what will be the number of degrees of freedom due to vibrational modes or due to vibrational motion? So each vibrational mode, see here you have to remember this. This is very important information. Very important information. So each mode of, like each vibrational mode has 2 degrees of freedom. Okay, 2 degrees of freedom. So this is where the critical concept was there in this problem. Otherwise, this three you can write down. Okay, so I have got total how much, like how many degrees of freedom for the given polyatomic gas. Now I'll write. See, there are 24 vibrational mode, so 2 into 24. Okay, so you have 3, 3, 6 and 48. So you will get total 54 degrees of freedom. Total degrees of freedom will be 54. Then what will be the value of this gamma? We know gamma is 1 plus 2 by f, 2 by 54. So which I can write 1 plus 1 over 27. Okay, so 1 over 27, if you just try to find out what is this decimal point, anyway you have got a 1 plus of some decimal number, so 1 over 27, that will give you nearly 1.037 kind of that. Okay, 037. So I have to take the nearest possible options here, so I'll take this one. Option B will be the correct answer, 1.03. So this is what you have to do for this question. Okay, so dear students, you have to see, only see when you have been given only vibrational modes, you don't stick to only vibrational modes. You have at the same time translational modes and also rotational modes, and this is polyatomic gas, so you have to consider 3 dimensions, okay, in 3 dimensions. So therefore you have to consider these 2 degrees of freedom as well. So there are actually very critical concept in this problem, okay, so that you have to actually understand and remember. So remember what you have to remember, that degrees of freedom in each vibrational mode will be 2. And when you are considering polyatomic gas and vibrational mode, number of vibrational modes are given, you should not stick to only the vibrational degrees of freedom. You have to be considering, you have to consider both the translational, rotational, along with the vibrational degrees of freedom. So these were few points to understand and remember. Now we'll solve the last problem. Okay, so this problem says a Carnot engine working between 400 Kelvin and 800 Kelvin. That means T1, that is the hot reservoir, temperature of hot reservoir we know 800 Kelvin, and the cold reservoir is T2, that is 400 Kelvin. Okay, so Carnot's engine, a Carnot's engine working between 400 and 800 Kelvin has work output. So work output is given, very nice, that is 1200 joule per cycle. Okay, the amount of heat energy supplied to the engine from the source in each cycle. So if these are the informations, you have to find out how much heat input is given. Okay, heat energy, how much heat energy is given to the Carnot engine in each cycle. See, temperatures are given, heat, see, our work output is given. What is missing? The information about efficiency is missing. We know information is, see, eta, efficiency eta is work output by heat input. Let us say this is heat input. We know this. So what we need to know? We need to know eta. Again, this efficiency eta can be written as 1 minus T2 by T1, where T2 is the temperature of the cold reservoir and T1 is the temperature of the hot reservoir. So from here actually we can find out what is eta. Eta is equal to 1 minus 400 by 800. So what we'll get? We'll get here half. So 1 minus half will be half. So we get eta is equal to half. Further, this eta is equal to W by Q in heat input. So we know this W. I can then find out what is Q in. Heat input is 2 into W. W is given as, see, 1200 joule. So it will be 2400 joule. Okay, this will be the heat input. So heat supplied, heat energy supplied to the Carnot engine in each cycle is 2400 joule. And see, the option B is the correct answer for this question. Okay, so with this I'll stop it here for today. Today we had discussed the numerical problems from the 11th part. In the next class we'll discuss the questions from the same paper, but we'll discuss the questions from the 12th part. Okay, and we'll continue this one day discussions of 11th part, another day we'll discuss questions from the 12th part, like that we'll finish. Okay, so all right, thank you for your patience.